So what we want to do is, it would be really nice. Now, I said earlier, and earlier this morning, I used IOStat as an example, bless you, where I like IOStat as an example set of ideal metrics for looking at any resource. And the reason is, there's my workload characterization, there's my latency analysis, and all three groups, well, actually not all three. There's workload characterizations there, latency analysis is here, and the use method is utilization, saturation, and errors, with the error column. So I love this because I can do 3 different methodologies for 3 different reasons on one set of metrics. So this is why I've encouraged other engineers to start with that group. Now that's for a resource, that's for a physical resource. What I'd like us to do is to split up into groups where we try to, in your group, think of what ideal metrics would you monitor for that target. Now that target might be a database. What's the ideal 5 metrics or 10 metrics you want to monitor for your database? Is it the request rate, mean latency, 99th percentile, full distribution? You want to throw that in as well so that you have it if you need it. What set of ideal metrics, and don't think about implementation. Don't think about can I or can't I do this. What ideal metrics would you like to see from these components? And I will write up the answers, or we'll write up the answers on the strip of whiteboard on the wall. And also these answers that we come up with might be, we were discussing earlier about sharing it with the community. And so we might get this on GitHub somehow, because it is something that developers ask. So I'm developing a monitoring product. What metrics should I stick in there? If we've come up with an ideal set that we feel has good coverage, that can drive a new generation of performance monitoring tools and products. But to break you guys into groups, what I need to do is figure out what generic targets would we like to monitor. In fact, this exercise, not to get off on a tangent, the only thing that's really tried to do this in the past would be SNMP. And so SNMP, generalized performance metrics, so that you can gather them for any type of product. It was done a very, very, very long time ago. We all know there's problems with it. It's great, but not so great. So this is a new exercise of figuring out what the targets of our analysis are, and then what ideal metrics we'd like to see for each. I just threw this together. What generic groups do we want to measure? So have a look at this list. What am I missing? What shouldn't be on it? So I've got devices. I guess I could call that resources. So I want to monitor hardware resources. The use method already does that, but web servers is a component of the environment. Application servers, databases, distributed systems. Am I missing? What am I missing? Surely I'm missing some things, or?
Well, some sort of notion of the interconnectedness of it. Most of those can be described as nodes in some sort of graph sense, but I don't know that you would apply any of those descriptions to say network links between the devices or between the servers.
Yeah, the interconnect could be part of distributed system analysis, I'm not sure. Or it could be treating the network as, could we treat the network as a device like a CPU or a disk?
I think the thing that's tricky is that it implicitly has topology, right? And so it's a bunch of links connected up in some topology, and it's tied to the workload.
Right.
This is the reason that we don't actually generally have good network models.
I was going to add configuration. Like, well, you should configuration on the correct reference. Well, that's kind of related to the network model.
Monitoring configuration. But would you be able to come up with a list of ideal metrics based on configuration?
Oh yeah, sure. So really what this is, the more generic version of John's idea here is metrics for process. Right? You're tracking
what my CM system says, for instance. So I can write it.
So the idea at a high level here is you've got all these management processes that you're performing as the normal maintenance and operations process for the system. And you actually want to think about what the model is for tracking those processes and understanding if they're working. I don't know that I'd go full to the Six Sigma kind of model, but I think it would make sense to.
A simple one that used to bite us was this job needs to run on an 8 gig image. And oh, look at this, it's accidentally a 4 gig image. What's catching that? It should be measuring what our configuration is versus reality. And that can help drive repairing stuff later. A lot of the case, of course, even in some of that configuration versus reality difference directly back into your provisioning system on IT interface.
So, are you guys familiar with static performance tuning? So I didn't put it on the list, but tell me if this sounds the same. Static performance tuning was popularized by Blueprint by Richard Elling in 2000. What it is you look at the configuration of the environment and the performance attributes of the environment when no load is applied. So how many CPUs do you have? How are they configured? How's network auto negotiation worked? Because it may have a bad cable and it may be working, but it's negotiated down to 100 megabits per second. What caches are enabled and turned on? I've had so many customer issues where they think they're using a cache, but it's not actually on. Cache hit rate is 0 because they messed up the config. And so with static performance tuning, it is just the configuration of the system. And you can turn off the workload and still do static performance tuning because you find they've misconfigured something. One last week was the compile options were wrong. And so they weren't using optimizations when they thought they were. And it's just the configuration of the system. Does that sound similar? Am I talking about the similar thing?
You kind of are, and that, like what you described about compile options, like monitoring to make sure that, for instance, a debug binary doesn't accidentally slip out into the production fleet.
Yep.
That's a key thing,
yep.
And it happens often enough that it's something that's a standard check.
Yep, static performance tuning, it covers, you're running debug binaries by mistake. You know, we have debug kernels, which their performance is just twice as bad as a normal kernel. Maybe there's kind of errors, but misconfiguration of RAID pools, all of that stuff. Static performance tuning. So, configuration. So that's a good one. That is a target. The way I think about it is this is the metrics I need to perform. I have not seen someone do a great job of static performance tuning you may already do it, but of static performance tuning as a monitoring service to see if changes in the environment screw it up. Another one I had recently, I bet we've all had this, where someone's using, I forget if it was Puppet or Chef, they've come up with a standard config in one data center, they've deployed it on a different data center, performance sucks, and we take a look at latencies and figure out they were using a local DNS server back in the first data center, and they hadn't updated their config. And again, it is just configuration. So yeah, absolutely, configuration, great type. What set of metrics could we, that would be a tough one to come up with a set of metrics, but it would be interesting to see what we can come up with. Now David said networking, and I was trying to get my head around whether networking was a resource or a device or a distributed system. The way networking has routers and switches and gateways, it is kind of its own thing. So it might be worth.
Well, it's really distributed. It is to some extent a distributed system, right?
Right.
The queuing, as the switch is buffering things locally with the input to the switch, with the output to the switch. And just like your disk hierarchy, those two should pretty much match up. If they don't, then it's just being buffered internally, the switch itself is causing a slowdown. And again, you're passing packets back and forth, which is simply a message passing bus or whatever in a distributed system. So I think you pull elements from both resource and device, and as well as distributed system into network.
Yep.
But what John is describing is also borderline lining into scheduling.
It's like scheduling.
It is scheduling, and it is the metrics that you use to make scheduling the decision. The interesting thing is that is also kind of the underlying topology is a moving target. Like you guys are doing, like use SDN for scheduling decisions now across data centers.
Well, no, schedule is over the.
You're not doing that at all?
No, terrifying. I was thinking, the kind of thing that is a wonderful commander, who's we worked recently on with guys in Dublin. What it does is, you just give it, here's the configuration file for my whole service, and this is like, these are 15 directories, each one configures a cluster, each cluster has front ends, back ends, monitoring, and you basically say, what is that? Tell me for the stack configuration and match that to what is in reality. And you'll see, oh look at this, for some reason one of those jobs is running an old version. This one here has some old flags. This cluster here, as you said, is configured to use a remote DNS, and it tries to work different.
That's the core model that we built pconfig around. It's this sort of reconciliation model. And I think that the more general version of this is from the 50,000 foot view, what you're doing is you're synthesizing metrics for the process of configuration deployment, right? And really what you want to think about is what are the underlying operations processes and what are the right metrics to expose for those. I think the configuration probably isn't the only one, but I can't think of another example off the top of my head.
So one of the other big ones to do is measure the process slips, and it's more important on the hardware side of things, where they'll say, here it is, we're I can't remember, something like 650 steps to the turn of any data set. And each one has this should take 8 hours, this one should take 15 seconds, this one should take 2 days. So when they're going through, various people like project managers or even directors might be interested in how those slips happen. And we use the same system for monitoring those process slips as we use for monitoring configuration problems in various places, or even RPC levels.
Yeah, we've seen similar things when our provisioning system goes belly up, and something's just not quite right.
So if you look at your provisioning system that's exploiting data, your standard monitoring system, whether it's Grandfather or whatever else you consume, you have a one like
Cool. We have 7 items. I think this is pretty good. Any last second changes to this list?
Message queuing, message bus, something like that. Messaging.
Messaging. Messaging.
You don't fold that under the distributed system.
Technically, none of those things are useful when they're not distributed, so I would
Right.
call all of those under distributed systems. But I think message queuing, the monitoring around message queuing, there are challenges in monitoring systems because they are distributed, and the challenges in monitoring messaging are not because they're distributed. That enables distributed systems as do web services and network infrastructure, but I think they have unique problem constraints.
Okay, we have 8, and we have about 24 people in the room, so that means groups of 3. This is how I'll do it. I will go through this list and volunteer for a topic that interests you, and once I hit 3, that's it. This encourages you to volunteer early, because if you don't volunteer for anything, then you will get whatever's at the end of the list, which is fine. It's still going to be useful. And so think about which of these you might want to work on. Should I do an ordering of these, or is that fine? I want to put this one at the end. It's the way I go around this. Configuration, infrastructure configuration. I want to start with a couple of. Actually, I want to go hard to easy. So I want to. It's not going to be easy. It's not going to be easy. Oops. That way, if I can get people to volunteer for the harder ones, then it might work well. Distributed systems needs to go up. Yep.
Distributed systems is
Trivial?
It's the cruel joke, right?
You're having me on. Move that up.
Oh, it's an alphabetical order now?
We beat web servers.
Okay. So I will pick 3 people, and what we'll do is we'll spend, what's the time now? It's coming up to 2. So up until 2:30, so we'll have half an hour should be plenty to you can do a bit of research on Google. You can type in configuration monitoring, see what's out there. Think about the methodologies I mentioned on the previous slide. Think about the problems that you're experienced with and what you'd like answers for. Ask me questions and ask any of us questions to come up with a list. And ideally, for each of these, I put this last because we've already kind of gone through this to some degree with the use method. For each of these, you want to be able to say, ideally, I'd measure utilization saturation errors or mean service time or whatever it is. As concise as possible. And then we'll write them all up on the whiteboard, and it'll be interesting to see what we can come up with. And again, it will be useful to bring reality into posing the questions, problems you've had before, but don't let reality bound your answers. We want to come up with ideal things, even if it's really hard. Even if it means digging into CPC counters, I want to know what's ideal for monitoring each of these. So, network infrastructure. So, I have, there's three, that's it. So it's Narayan, Peter, and Adam, you guys, thanks. Do you want to introduce yourself quickly to everyone?
Yeah,
like,
sorry.
1 second.
Adam left from WebMD, based here in Ashburn, Virginia.
Great, thanks. Okay, you three guys, network infrastructure. Configuration. I'm looking at John because John has some experience. I will pick on John and Corey and Ajay. Great. Distributed system. Excellent. So I've got Scar and, sorry, I forget your name, was John and Laura. Great. Message queuing. Message queuing. Oh, I saw a hand from Theo. Thank you. Theo and Scott. It's going to be a hard problem. I really want Theo to. And your name?
John.
John. Great. Web service. Kasky and David.
Dave.
Dave, sorry. And Will. Great. Application servers. Application servers where it's like some, yes? Alex and Ken.
Finish your description.
It's whatever application you're running. It may be I'm running a shop and it's processing, needs to process orders. So it's some custom application or, yes. So I had, what's your name? Alex and Patrick and Ken. Great. Remember who your partners are for the next 30 minutes. Databases. Your name? Nathan. And I saw another hand. Okay, who hasn't put their hand up? Hands up if you haven't volunteered yet. No, you already have. What's that?
We volunteered.
Oh, okay, you're right. It's a different question. Okay. Put your hands up if you aren't associated yet. So 1, 2. So who already put their hand up for databases? Okay, so Nathan, Michael, and Leanne. Great. Who's left? Resources and devices. What's that? There's no reason. If I will do this myself, if there's no one left.
24 people in this room, don't we?
Yeah. Did I count wrong?
Not to be involved in anything, but it didn't work.
You're welcome.
I would have the ET input on that distributed systems is harder than a 3-person
Okay. We'll find out. 30 minutes. You'll need to stand up and talk to your lab partners. Please feel free to ask me questions.
We can also throw out more whiteboards.
We can throw up more whiteboards.
You have more markers.
Or does it at the timestamp?
It's like some evolutionary,
Yeah, you gotta run. You don't want to be stuck there.
21 seconds is apparently the right amount of time to
I think okay, so we're starting with a little other network. Well, I mean, we can pick methodology, but also
if you guys need some more
Right, because
No, it's we have one, it's just much smaller.
it's called saturation. So head is saturation